biped. As it says, it's a two-legged robot that does not look like a human. So how does it walk? It walks like this. Simple, stable, low cost. Very simple. It walks like that. Now, I briefly mentioned about a robot called Sapphire for firefighting on military ships. If you've been onto a Navy ship, when you open the door, it has a very high door seal. So for the Sapphire project, to go over it, you had to brace and do something like this, which was very, very difficult to do. Now, if your robot doesn't have to be in the human configuration, you can do something like this. Rotate the knee 360 degrees. Brilliant. Our robots can climb steps, but it's difficult. So now we do something like this. Now, is this all animation and simulation? No. In 2 weeks, from the idea to analysis to implementation, in 2 weeks, we build our first prototype, and you haven't seen anything like this.
You're wild.
It can show emotion by motion. If you meet a Navi for the first time, he's very happy to see you. It's like, hello everybody, my name is Navi, right? It can also hop and jump using the spring-like leg. If you have time, we'll talk about this, but it can jump and hop like this. It's a very interesting robot. It solves a lot of problems. So this is Navi. Would you like to see Navi? All right, do we have Navi? All right, bring it over. So what you see over here is our first early prototype Navi. Okay, just going to do a quick walk, just make it walk a little bit. It's very, very stable. I want to emphasize that this is a fully open loop. There are no sensors on it. Even with open loop, it can walk very, very stable. Now, can you imagine by having an eye and closing the loop, this will be able to walk on uneven terrain and do many, many things. Thank you very much. So with this robot, can you continue the slides, please? Yeah. Our vision is to use these for many different applications. For example, autonomous car pulls up and it wants to deliver a package. What do you do from the car to the actual person? Our robot walks like this. The head opens up, picks up the package, and puts his head, which means that we need to have arms, right? Now we have arms, so let's use them as limbs so that it walks up to the sidewalk. It can jump, hop like this, right? We have a new locomotion method called scrambling walk for uneven terrain. Climb upstairs, use the limbs as hands to open the door. In a hallway, lift your arms, and it becomes a humanoid form, and then deliver the package. So to do this, we need to have two limbs. Thus, we develop a new robot called Alfred, autonomous leg personal helper robot with enhanced dynamics. And we have Alfred on stage as well. So this is Alfred. We call that 4 limbs, not legs, not arms, because these limbs can be used for both locomotion and manipulation. We call this multimodal locomotion because it has many different ways. Oh, by the way, if you hear the sound, I don't know if you can hear it, this is not an internal combustion engine. When you do robotics research and development, you need to monitor a lot of parameters. In this case, you want to monitor the current. So we have a speaker. Do you hear it? Engine sound, that's actually the current draw. So as you can imagine, it can have a wide sprawl quadruped walking. So wide sprawl, stable but slow. Now, if you want to go really fast, it changes configuration to more like a dog or a horse, and you can walk really. Don't make it go too fast. We don't have a lot of space. Okay, make it go run this way a little bit. Dynamic quadruped walking. Okay, good. All right, cool. And then we haven't implemented just yet, but we'll be able to do this and do a somersault kind of motion as a wheel. And if you fold his legs like this, it becomes more of a humanoid type bipedal walking. And of course, you lift this arms like this, it becomes like the Navi type of locomotion. Cool, thank you very much. So this is Alfred. Cool, let's have the slides back up. Thank you. So we talked about different type of configurations, but another important thing is the actuator.